Oh my gosh, why does every time we come to the stop, this baby has to start crying?
It's not my fault. You raised a baby that doesn't like to sleep in the car.
Well, you are the one that had to have the baby.
Well, you know what? Maybe that's a problem we need to deal with at another time, okay?
Gosh, just get it to stop crying.
How am I supposed to get the baby to stop crying?
I don't know. Come up with something.
There's no way to make a baby stop crying whenever a car comes to stop. It's like a law of science. It always happens. There's no way around it.
Somebody has to come up with something. This is ridiculous.
So what our baby seat does is when the car comes to a stop, the base is going to start vibrating. And how we do that is we use an accelerometer to measure the vibrations of the car. And then when the vibrations become too low, we have a homemade vibrator made from a motor and a piece of metal that will make it vibrate. So just to show you what happens, when you turn it on, it'll vibrate, and the baby's vibrating. And then when the car starts moving, it'll stop vibrating. Stops again, it'll start vibrating. So if the baby starts crying, then we also have a sound impact sensor that will sense when the baby starts crying that turns on a servo for a mobile. And the mobile turns on.
Alright, so now for the hardware. Right here we have the vibrator stuck inside the foam board. And we have the mobile that we made out of the servo from the Bobot. And we have the wire for the mobile coming down into the base and connecting to the breadboard and the motherboard right here. And then we also have the sound impact sensor right here. And that is also wired down into it. And we have our power supply that's connected to a switch inside to power off and on. And then it all comes to the breadboard that has everything plugged in with the accelerometer and the sound impact sensor.
Now for the more technical side of our project. We used our Arduino environment to use accelerometer and the sound sensor to detect changes in the baby seat's surroundings. Normally, we would want to turn the vibration motor off immediately after the accelerometer gives us a reading that's too high. However, the accelerometer doesn't give us data that's immediately useful to us. When we read in data from the accelerometer, we find the difference between that reading and the reading before it to find the change in value. Next, we take the average of the last 3 of these changes in value in each direction, giving us an X average and a Y average. The program uses these averages to decide whether to turn the vibration motor on or off. If either average goes above the set point, the vibration motor will turn off. If both averages are below the set point, the motor will turn on. After we deal with the accelerometer, we move on to the sound sensor. The sensor will give us a 1 if the noise level is above a set point, and a 0 if the noise level is below a set point. Instead of turning on the mobile immediately after we get a 1 from the sound sensor, we take the average of these noise readings over the last 2 seconds. If the noise level average was too loud for the majority of the last 2 seconds, then the mobile will start spinning. It will continue spinning until it reaches the end of its dead time, where it will start listening for noise levels again.